This is Pre-Calculus, Chapter 3, Test Review. We need to use the graph of f of x to describe the transformation that results in the graph of g of x. Now remember, when you have something with the x value, when you pull it out, you need to change the sign. So we would need to translate the graph 1 unit to the left. And then if there's anything added or subtracted after the function, that is going to translate either up or down. So we are going to translate down 5 units since it's negative. Again, we're going to describe the translation or the transformation. Because we have a negative attached just on the x, not on the entire function itself, that means we are going to reflect across the y-axis. We have a 3 multiplied by just the x, so that means it's going to be a horizontal dilation. Because this number is greater than 1, it means we are going to reduce horizontally by a factor of 3. And we have this minus 5 after the function, so that's either going to translate up or down. And we are going to translate down 5 units. We need to express this logarithm in terms of ln of 2 and ln of 5. Now 25 we can split to be 5 and 5. 4 we can split to be 2 and 2. So we can write this as the ln of 5 squared over 2 squared. Now division can be separated into subtraction. So we can write this as ln of 5 squared minus ln of 2 squared. And anything that is an exponent can be brought to the front. So we can write this as 2 ln of 5 minus 2 ln of 2. Evaluate the logarithm. To do this, the first thing we're going to do is instead of writing this as a root, we're going to write it as an exponent. So the 6th root is the same thing as writing this to the 1/6 power. Now this is a base of 3, so we want to get this in terms of 3 as well. So we can see that 243 is actually 3 to the 5th power. Now when you have a power to a power, you are going to multiply. So this is going to give me log base 3 of 3 raised to the 5 times 1/6 is going to give me 5/6. The log base 3 and the 3 are going to cancel each other, and you'll just be left with the 5/6. We're going to evaluate the logarithm. Remember, if you have any exponents, you can bring them out front. So this is going to be 3 times 7 ln of e plus 5 times 2 ln of e. 3 times 7 gives me 21. 5 times 2 gives me 10. And ln of e just cancels each other out. So we're left with 21 plus 10, which is 31. Brody acquired an inheritance of $25,000 at age 3, but he will not have access until he turns 20. If his inheritance is placed in a savings account earning 5.2% interest compounded quarterly, how much will Brady's inheritance be worth on his 25th birthday? So our initial amount, our P value, is $25,000. We know our interest rate, written as a decimal, is 0.052. We know the amount of time from the time he is 3 until he turns 20 is 17 years. And we know the number of times it is compounded is quarterly, and there's 4 quarters in a year. So our n value is 4. Now the formula for this is p times 1 plus r over n raised to the nt power. So we can do 25,000 times 1 plus 0.052 over 4 raised to the 17 times 4 power. And this means on his 20th birthday, he should have $60,575.56. Now, if we change this, and his interest rate is now 0.62, and it is compounded continuously, that is a different formula. That's p times e raised to the rt power. We're still going to have that 25,000 times e raised to the rate times time, which is 0.062 times 17. And if we do that calculation, if he would have found some place to invest his money where it earned 6.2% compounded continuously, he would have earned $71,727.62 by his 20th birthday. We need to expand the expression. So first we're going to take anything that is multiple division, since this is a fraction, and turn it to subtraction. So this is going to be log base 3 of 4df to the 5th minus log base 3 of the 8th root of 1 minus 3d. Now, this root we are going to make as an exponent instead, and the 8th root is the same thing as raising it to the 1/8 power. We can also expand the multiplication out front, and multiplication expands to addition. So we can say log base 3 of 4 plus log base 3 of d plus log base 3 of f to the 5th. And then again, we're going to change that root into an exponent. And the 8th root is the 1/8 power. Now, any exponent can be brought to the front. So when we write this, we can have log base 3 of 4 plus log base 3 of d plus 5 times the log base 3 of f minus 1/8 log base 3 of 1 minus 3d. Now we're going to take an expanded one and we are going to condense. To do this, the first thing you're going to do is get rid of any value that is out front and put it back as an exponent. So we're going to have log base 6 of 5a squared plus log base 6b plus log base 6 of c to the 3rd power. Now we can go ahead and square those pieces in that first part. So we can write this as 5 squared is 25, a squared. In addition, when you condense it, it becomes multiplication. So we can write this as log base 6 of 25a squared, b, c to the 3rd. Jordan wrote an exponential equation to model the cost of gasoline. He found that the average cost per gallon in 1990 was $1.80, and the average cost of gasoline in 2011 was $3.57. If the average cost of gasoline increases at an exponential rate, identify the rate of increase. Write an exponential equation to model this situation. So we know in year 0, or our n sub 0, that the cost was $1.08. We also know that from 1990 to 2011, is 21 years. So we know n sub 21 is $3.57. The equation for an exponential is n sub t is equal to n sub 0 times 1 plus r raised to the t power. So if we substitute the information that we know n sub t is 357, our n sub 0 is 1.08, and we know that from 1990 to 2011 is 21 years. Now we want to get that r value by itself. So the first thing we can do is divide both sides by 108. I'm going to go ahead and leave that in the fraction form right now so that we don't round. Now the next thing we need to do is to get rid of that 21st power. So we would take the 21st root of both sides. If you take the 21st root of 3.57 divided by 1.8, you're going to get approximately 1.06. Is that equal to 1 plus r? To get the r by itself, we will subtract 1 from both sides, and you're going to get the r is equal to 0.06. Now we need to write the actual exponential equation. So we're going to plug that back in, and we're going to say n sub t is equal to n sub 0 times 1 plus r raised to the t power. You can leave it in this form, or if you want to simplify it and write it as n sub t is equal to 1.08 times 1.06 raised to the t power, that would be acceptable as well. Now we need to use this model to predict the cost of gasoline in 2018. So we're still starting with that n sub t is equal to 1.08 times 1.06 raised to the t power. And we know that 2018 is 28 years after 1990. So we're going to plug in 28 as our value for t. And if we solve this, we're going to say if this was an exponential model and it continued at this rate, that the cost would be $5.52 by 2018. And luckily, this exponential model was not correct, and gas did not reach that price by 2018. We need to evaluate this logarithm. Since this is not a base of 10 or a base of e, we're going to have to use our change of base formula. So we're going to do the log of 22 divided by the log of 15, and that's just going to give us 1.14. Solve the exponential equation. To be able to solve this, we either have to get the two bases the same, or we have to get the variable out of the exponent. In this case, it's easy to see that we can write 49 as 7 squared. When you have a power to a power, you can multiply. So we can write this as 2 times x is 2x, 2 times 6 gives us 12. Since the bases are the same, we know the exponents must also be equal. So we know that x plus 2 must equal 2x plus 12. If we solve for x, we're going to get 2 is equal to x plus 12. Subtract the 12 from both sides. And we're going to get that negative 10 is equal to x. Solve the logarithmic equation. To do this, we're trying to get the log part by itself. So the first thing we can do is subtract 4 from both sides. Now we have 8 times the log, so we can divide both sides by 8. Now we have log base 3 of g. To get rid of the log base 3, we need to raise everything to an exponent. So I can put a 3 out front here, put a 3 out front here, make everything our exponent. So this is 3 log base 3 of g is equal to 3 squared. The 3 log base 3 will cancel. So on the left side, you're just left with g, and 3 squared is going to give you 9. We need to solve the equation. If you notice, we just have one log with a whole bunch of stuff on the left and one log with stuff on the right. Now, because both of them are log base 8, we can just pull the stuff out of the two logs. They must be equal to each other. And we can just say x squared plus 11 is equal to 92. So to solve this, we are going to subtract both sides by 11. And we're going to see that x squared is equal to 81. To get the x by itself, we're going to take the square root. Remember, when you take the square root, you are going to have plus or minus. So we're going to have x is equal to plus or minus 9. Now, because when you have that plus or minus, you may end up with extraneous solutions. You should plug it back in to make sure it makes sense. A negative 9 squared is a positive 81 plus 11. You can take a log of a positive number, so we are good in that case. Solve the equation round to the nearest hundredth. So we want to get, again, that variable by itself. So we're going to add 0.3 to both sides. That's going to give us 0.75 e to the 3.4x is equal to 80.4. Let's fix that. Now it's 0.75 times that quantity, so the opposite of multiply is divide. Now, to get rid of the e, you are going to take the ln of both sides. The ln and the e will cancel, so we have 3.4x is equal to the ln of 107.2. To get the x by itself, we are going to divide both sides by 3.4. And we will be left with x is equal to 1.37. Now, to be able to solve this one, if you can see, we have e to the 8x, e to the 4x, and then we have a constant. So we are actually going to factor this one. Now, what multiplies to get 2e to the 8x? We have 2e to the 4x and e to the 4x. We need to know what multiplies to get a negative 1. So we have 1 and 1. We just have to decide where the positive and negatives go. Remember, the O and the I, when you multiply the outside and the inside, when you put those two together, you do want to end up with a positive 1 here. So if we have plus here and a minus here, if we check the O and the I, 2 times 1 gives me 2e to the 4x. The inside part is negative 1e to the 4x, and together, that's going to give us a positive 1e to the 4x, which is what we wanted here. So we are good on our factoring. Now we need to solve. So we are going to set each of these equal to 0, and we're going to solve. So if we add 1 to both sides here, that's going to leave us with 2e to the 4x is equal to 1. If we subtract 1 here, we're going to be left with e to the 4x is equal to negative 1. Now on the right side, the e part is by itself, so we are good. On the left side, we do need to divide both sides by 2 to get the e by itself. Now, to get rid of the e, we are going to take the ln of both sides. Now, the ln and the e are going to cancel. So we're going to be left on the left side with 4x is equal to the ln of 1/2. On the right side, we're going to be left with 4x equals, but we're trying to take the ln of -1. You cannot take the log of a negative number, so on this side, this is actually not possible. But we still need to finish solving the left side. To get the x by itself, we're going to divide both sides by 4. And we're going to be left with x is equal to negative 0.17. We need to solve the equation round to the nearest hundredth. As we had stated previously, if we can get the two bases to be the same, then the two exponents can just equal. But there's no way that we can simplify 9 and 2 so that the bases are the same. So instead, we are going to have to take the log of both sides. So we're going to say the log of 9 raised to the x plus 2 is equal to the log of 2 raised to the 5x minus 4. Now we know when we have logs, anything that is in the exponent can be brought down front. So we can say x plus 2 times the log of 9 is equal to the 5x minus 4 times log of 2. Now we can take the log and distribute it to both pieces. So this is going to give me x log of 9 plus 2 log of 9 is equal to 5x log of 2 minus 4 log of 2. We're solving for x, so we want to get all the x's on one side, everything else to the other. So first we're going to subtract that 5x log of 2 from both sides. So that's going to leave us with x log of 9 minus 5x log of 2 plus 2 log of 9 is equal to negative 4 log of 2. We need to move the part that doesn't have an x to the other side. So we're going to subtract that 2 log of 9 from both sides. And that'll leave us with x log of 9 minus 5x log of 2 is equal to negative 4 log of 2 minus 2 log of 9. Now if you notice on the left part, each piece has an x. So we can factor those x's out. So we're going to have x times the log of 9 minus 5 log of 2 is equal to negative 4 log of 9 log of 2, minus 2 log of 9. Now we have x times that whole quantity, so to get x by itself, we are going to divide by the log of 9 minus 5 log of 2. When you put that into your calculator, make sure you have parentheses around the numerator and the denominator so the calculator does the calculation correctly. And you should end up with x is equal to 5.65. We need to solve the logarithm. The first thing we can do is we can get this 2 that is out front back up as an exponent. So that'll give us the ln of 9x to the 4th minus ln of 2x squared minus 1. We do this because we're going to try to condense this down as far as we can and then get rid of our logarithms. Now subtraction, we know we can condense and make division. So we have the ln of 5x squared plus 4 is equal to the ln of 9x to the 4th over 2x squared minus 1. Since we just have an ln of a quantity on the left and an ln of one big quantity on the right, we can get rid of the ln's and just set the pieces equal to each other. Now we need to get that x out of the denominator, so we can multiply both sides by 2x minus 1, 2x squared minus 1. So over here we can cancel. On the left side, we have 2x squared minus 1 times 5x squared plus 4. So we are going to have to FOIL. So remember, you multiply the first pieces, so that's going to give us 10x to the 4th. Outside is plus 8x squared. Inside is minus 5x squared. And last will give us negative 4. If we take the 9x to the 4th to the other side and condense all at once, we're going to get x to the 4th plus 3x squared minus 4 is equal to 0. From here we can factor. So we have x squared and x squared. What multiplies to get a negative 4 that adds to get a positive 3 is a 4 and a 1. So we can set each of these equal to 0 and solve for x. To do that, we're going to take the 4 to the other side and the 1 to the other side. To get rid of the square, you are going to take the square root. Remember, when you take the square root, you have to have the plus and the minus. Over here, you cannot take the square root of a negative number, so that part is gone. But on the right side, we're going to have plus or minus 1. Now, we do need to make sure both of these are going to work. You need to check for extraneous solutions. Remember, you cannot take the log of a negative number. So if we plug in a negative 1, 5 times negative 1 squared. Negative 1 squared is a positive 1 times 5, which would give us 5 plus 4, works there. 3 times negative 1 squared would give us a 3. We're good on that one. And 2 times negative 1 squared. Negative 1 squared is positive times 2 is 2 minus 1. We are good there as well. So both solutions are possible. We need to solve the logarithmic equation. Now, we cannot get one log on both sides and nothing else, but we can get the two logs together. So if we subtract that log of 2x from both sides, so we have all the logs on one side. So this is log of 3x plus 2 minus the log of 2x is equal to 1. Now we can condense on the left side. Remember, subtraction turns into division. So we have the log of 3x plus 2 over 2x is equal to 1. Now remember, if it's just plain log, it actually means this is log base 10. So we can raise everything so that these are our exponents, and we have a base of 10. So this is 10 raised to the log base 10 of 3x plus 2 over 2x is equal to 10 raised to the first power. Now on the left side, the 10 and log base 10 are going to cancel. So you're going to be left with 3x plus 2 over 2x, and 10 to the first power is just 10. We can multiply both sides by 2x to get that out of the denominator. And we're going to have 3x plus 2 is equal to 10 times 2x is going to give us 20x. To solve for x, we can subtract the 3x from both sides. Right now we have 17 times x. The opposite of multiply is divide. And we're going to get the x is equal to 2 over 17.